Hello, welcome back to Project Hercules Diaries. This video is to answer a question that's been asked a couple of times by Phil65. I don't know if that's someone who's 65 years old or was born in 1965 or the 65th person called Phil to get on YouTube. Anyway, that bit's not important. The question was, why isn't the sleeve pressure fed with lubrication? Because it's running up and down inside the cylinder and there's a large contact area. I think that's the general basis of the question. Well, it isn't in fact running in contact with the engine case. The sleeve has a clearance between the engine case, you can see there, on all the way around. So the sleeve isn't in contact with the engine case. And similarly, although it may not be very apparent, there is clearance between the sleeve and the engine case, or sorry, the sleeve in the barrel. This isn't a pressure tight seal. We're not relying on the clearance or lack of clearance between the sleeve and the cylinder to give us a pressure tight seal. What happens is the sleeve is guided by a contraction ring which is halfway up the cylinder. It's about here, and what the contraction ring does, unlike a piston ring that expands, a contraction ring contracts on the outside of the sleeve, and it serves two purposes. One is it guides the sleeve as it goes up and down, but the main purpose is to stop oil going up the clearance between the sleeve and the cylinder, because if any oil that's thrown up by the crankshaft goes on the sleeve and gets up past that ring, it's going to find its way into the inlet here and into the exhaust, and you get an engine that smokes like buggery. I've seen it happen on a friend's sleeve valve, and it's like James Bond when you turn on the smoke machine, or Spy Hunter. There's clouds of white smoke everywhere. It'd never get through an MOT or an SVA test. So that's something we don't want. So you can see the witness mark there, just about. There's like a witness mark. It's just oil that's been scraped back down by the contraction ring in the barrel. So that's what guides the sleeve at the bottom, and at the top of the sleeve is guided by the rings in the cylinder head, and that's a cylinder head there. Cylinder head's quite deep. It's like an upside down piston. Because the head is upside down, it's like a right way up piston. So the sleeve is inside the top of the, imagine this is upside down, so the top of the sleeve runs outside of the cylinder head, and it's the cylinder head that holds the sleeve in position and provides that clearance all the way around the barrel for the sleeve. So the sleeve is running between the rings on the cylinder head on the inside of the sleeve at the top, and the contraction ring on the outside of the sleeve at the bottom, and those are the only 2 points of contact between the sleeve and the barrel. So that's why it isn't lubricated. It's not required to be lubricated. What you can see on this other Bristol Hercules sleeve I've got here, you can see there's two witness marks here. This must have been off one of the lower barrels, because being a radial engine, the lower barrels will be at the bottom of the engine, and they were more prone to oil getting past the sleeve, so they had two contraction rings. Or it's from a later variant of the same engine, and you can see here clearly that's the sleeve travel, and the two contraction rings have given us these wear marks here. And in the top of the cylinder, you can see that there are witness marks between there and there. That's the travel of the rings of the cylinder head on the inside of the sleeve. So they're really the only points of contact. So it doesn't need to have its own pressure oil feed. The splash lubrication will come from the half moons on the crankshaft, and that will be wet, quite wet, because the scavenge pickup is here. And if you imagine the engine will be at a similar angle, so that's that position of this and the orientation of the engine give us the oil level in the bottom, and there will be quite a bit of oil flung up. What is pressure fed? We have a pressure feed through here. This is a mock-up, so that will go to the main bearing, and that then falls down on the other side inside the crankshaft. And we have a pressure feed to here, the only plain bearing, the only plain bush on the whole engine, and that is the drive pin that drives the sleeve up and down. So any splashback from here will come into this void, through the sleeve drive bearing and dribble down here, through into this cavity here, keeping the chain nice and wet, through the main bearings on this side and through the other side of the engine, and that will then come ultimately dribble down here into the bottom where it gets picked up by the scavenge pump, and you've seen the videos for drilling those holes there. So hopefully that answers the question. That gives you a bit more perspective of sort of how it works. Now we've got a working, well, it's not working, you know, a put together version, so you can see a bit more about what's going on. Hope that answers your question. Any more, pop them in the comments and I'll do my best to answer those. Anybody else that didn't ask the question, obviously, like asking for a friend, now you know the answer. Great. Thanks for watching. Speak to you soon.